All right, little break from graphing for right now. So we're going to talk about quadratic functions and solving them by factoring. So let's recall that the standard form, of a quadratic equation is ax squared plus bx plus c. All right, when we talk about the factored form, you're going to see something like r times x minus p, x minus q equals 0. So p and q are representing the x-intercepts, and what you're going to do is you're actually going to be coming up with the graph itself, or the equation itself. Okay, so we're sort of going backwards for this initial part. So it says to go from the factored form to the standard form, we're going to use the FOIL method. So for example 1, it says write a quadratic equation in standard form with the given roots. So what we've been doing so far is finding the roots. Now we're going the other way. So for the first one, we're saying that x is 1/2, and we're saying x is -5. So this is like your p, and this is like your q. And what we're going to sub it into is the formula x minus p, x minus q equals 0. So we're going to say x minus 1/2 times x minus a -5 equals 0. So let's simplify. So x minus 1/2 and x plus 5. Let's get rid of that double negative. And then you can't have fractions in here, so we got to get rid of the fractions. So we're going to move this denominator up to the coefficient with the x, so we get 2x minus 1. Because remember, if you were going the other way and you were solving, we would set the 2x minus 1 equal to 0 and solve, and you get 1/2. So they would match up. But the point is you're not supposed to have fractions in your answer. And then at this point, this is where you want to FOIL. So, because we're writing a quadratic. So when we FOIL, we get 2x squared plus 10x minus 1x is plus 9x minus 5 equals 0. And that's the final answer that you would leave on your paper. But again, you should not have, there should be no fractions. So maybe make a little note of this. No fractions in the equation. In the equation. So I started out with the harder one. Now we're going to go to the easier one. So we have -6, x is -6, and x is -3. So let's sub it into x minus p and x minus q equals 0. So we get x plus 6 and x plus 3. When we FOIL this, we get x squared plus 3x and 6x makes 9x plus 18 equals 0. We don't have fractions, and we're good to go there. So we know that we have to solve a quadratic equation as opposed to simply factoring when we see an equal sign. So when we see equals, we know we have to actually solve the problem out. So there's something called a zero product property, which says that if a, b equals 0, so if you have two things that are multiplied and they equal 0, then you have a couple options. Either a is 0, b is 0, or both are equal to 0. So that's always how we've gone about solving these types of questions, process-wise. So let's see, the first one, we have 9y squared plus 3y equals 0. Well, this is a GCF situation. So I'm going to take out a 3y, which leaves a 3y plus 1 left over. And now what I'm going to do is I'm going to take each part and set it equal to 0. So I get 0 for the first one, and -1/3 for the second one. And those are my two solutions for that. For b, I'm going to take a 5a out. I get an a minus 4. And again, I'm going to take the two parts and set them equal to 0. So I get a equals 0 and a equals 4. And those are two answers. Usually you can match it. The exponent value is equal to how many solutions you have. So for these, they're all quadratic, so anticipate having two answers. For C, step 1, I have to move that 15 over first. And then this becomes a trinomial. So a times c is -15, b is -2, so that would be -5 and 3. I'm going to set up my two fractions with my 1 as my numerator. So I have -5 and 3, which both are reduced. Top goes with the variable, So I get x minus 5, x plus 3, and then I set each one of those equal to 0 and solve. So when I do that, I should get x equals positive 5 and x equals negative 3. All right, same idea here. So a times c is 64, b is negative 16, so that's negative 8 and negative 8. Make my fractions. 1 over negative 8 stays 1 over negative 8, and 1 over negative 8 stays 1 over negative 8. Top goes with the variable, so I get x minus 8, x minus 8, and if I set each of those equal to 0, you'll find they're the same thing, so I get x equals 8. You don't need to write it twice. This is actually something called a double root, just because the value repeats itself. So again, don't write it twice, just write it once, and then you can indicate the fact that it is a double root. All right, next one, or next two here, let's see. So continuing with the factoring approach, there's our trinomial approach. So we are looking for two numbers that make 5 times 24, and 5 times 24 is 120, and they add up to 34. So go through your ideas in terms of what those numbers could be, but that would be 30 and 4. Okay, so if we make our fractions 5 over 30 and 5 over 4, the 5 over 30 becomes 1 over 6, 5 over 4 stays 5 over 4, and we get x plus 6 and 5x plus 4. Set each one equal to 0, and you get a negative 6 and a negative 4/5. Again, no particular order in terms of which way you put parentheses. You just need to have both of them. All right, with f, we're looking for two numbers, a times c, that multiply to get 120 again. And in this case, now they got to add to get negative 23. So we're going to use negative 8 and negative 15. Oops, sorry. So we get 6 over negative 8, 6 over negative 15. When we reduce that, we get 3 over negative 4. When we reduce by 3, we get 2 over negative 5. Top, it's now a y. So we get 3y minus 4 and 2y minus 5. Set it equal to 0, and we take each parentheses, set it equal, and we end up with a positive 4/3, and we end up with a positive 5/2 for your final answer for those. All right, couple more. So we have x squared minus 21. Well, that's two terms, so this is a difference of squares for x minus 11, x plus 11. Set each part equal to 0, and you get 11, and you get negative 11 for your two answers. For h, you got to bring the 25 over first. Set it equal to 0, and again, difference of squares. So 6x minus 5, 6x plus 5. Set each part equal to 0, and you get 5/6, and you get negative 5/6 for those. All right, last two. So we're looking for two numbers that multiply to get 9 and add to get negative 6. So that's negative 3 and negative 3. So if we set up our two fractions, remember the negative has to stay in the bottom and it needs to remain a fraction. So we're dealing with a's here. So we get 3a minus 1, 3a minus 1. Set each part equal to 0, and you get a equals 1/3, which again, just like we did on the front side, that is a double root. So even though it looks like one answer, it's not. It's two answers. Now with J, the first thing you have to do is they have a GCF of 4. So let's take that out first. And then we're looking and saying, all right, I need two numbers that multiply get 4 times 9, which is 36, and adds to get 12. So that would put me at 6 and 6. So I'm going to do 4 over 6, which is 2/3, and 4 over 6, which is 2/3. Top goes with the variable. So we had the 4 in front, and then we have 2x plus 3, 2x plus 3. Set each part equal to 0. 4 equals 0, and 2x plus 3 equals 0. Well, 4 equals 0 doesn't make sense.